Hello everyone, I welcome all of you to my channel Knowledge Center. Myself Kumar and today we will discuss our next part of IIT JEE series. इससे पहले जो हमारा पार्ट 9 था, पार्ट 9 में हम डिस्कस किया था हमारा टॉपिक काइनेमैटिक्स का पार्ट 1। अगर आप लोगों ने पार्ट 9 नहीं देखा है पार्ट 9 का लिंक मैं यहाँ पर डाल दूंगा, आप वहाँ से पार्ट 9 को देख सकते हैं। इसके अलावा हमारे जितने भी बाकी वीडियोस हैं पार्ट 1 से लेकर पार्ट 8 तक, आप उन सभी वीडियोस को हमारे चैनल के माध्यम से देख सकते हैं। ओके, एंड आई रिक्वेस्ट एवरीवन, इफ़ यू लाइक माय वीडियोस प्लीज़ डू सब्सक्राइब टू माय चैनल एंड कीप लर्निंग। हमारा आज का टॉपिक है एनसीईआरटी सॉल्यूशंस फॉर द टॉपिक मोशन इन अ स्ट्रेट लाइन। जितने भी क्वेश्चंस हैं इस टॉपिक के, उन सभी क्वेश्चंस को आज हम लोग स्टेप बाय स्टेप सॉल्व करने वाले हैं। आई होप यू ऑल आर रेडी फॉर इट। नाउ लेट्स बिगिन विद आवर फर्स्ट क्वेश्चन। एज यू कैन सी ऑन द स्क्रीन, जो फर्स्ट क्वेश्चन इट इज सेज दैट इन विच ऑफ द फॉलोइंग एग्जाम्पल ऑफ मोशन कैन द बॉडी बी कंसिडर्ड अप्रॉक्सीमेटली अ पॉइंट ऑब्जेक्ट। हमारे पास चार ऑप्शंस गिवन है। ऑप्शन ए, a railway carriage moving without jerk between two stations. Option B, a monkey sitting on top of a man cycling smoothly on a circular track. And the next one is a spinning cricket ball that turns sharply on hitting the ground. And the D one is a tumbling beaker that has slipped off the edge of a table. अगर हम ऑप्शन ए को ध्यान से देखें, फॉर एग्जाम्पल अगर एक रेलवे कैरेज है, अगर स्टेशन ए से स्टेशन बी के बीच ये डिस्टेंस ट्रेवल करता है, तो जो डिस्टेंस होगा वो बहुत बड़ा होगा और इस डिस्टेंस के कंपैरिजन में जो रेलवे कैरेज होगा बहुत छोटा होगा। तो हम लोग कह सकते हैं कि ऑप्शन ए दैट विल बी द राइट आंसर। ऑप्शन बी भी हो सकता है। यू कैन सी हियर, जो मंकी है दैट इज सिटिंग ऑन अ टॉप ऑफ अ मैन एंड द मैन इज साइकिलिंग स्मूथली ऑन अ सर्कुलर ट्रैक। अगर हमारे पास एक सर्कुलर ट्रैक है, इस ट्रैक के रिस्पेक्ट में, इसके कंपैरिजन में जो मैन होगा जो साइकिल चला रहा है वो काफ़ी छोटा होगा। तो हम लोग कह सकते हैं कि ऑप्शन बी दैट विल बी आवर राइट आंसर। वी कैन कंसिडर ऑप्शन ए एंड ऑप्शन बी। नाउ वी हैव आवर नेक्स्ट क्वेश्चन हियर। क्वेश्चन सेज अ वीमेन स्टार्ट फ्रॉम हर होम एट 9 AM एंड सी वॉक्स विद द स्पीड ऑफ 5 kmph ऑन अ स्ट्रेट रोड अप टू हर ऑफिस 2.5 kilometers away and stays at the office up to 5 p.m. and returns home by an auto with a speed of 25 kmph. We have to choose suitable scales and we have to plot the xt graph of her motion. Women ने अपने जर्नी को 9 AM पर शुरू किया और women after some time अपने ऑफिस पहुंच जाती है। I want to find out the time taken by the women to reach the office. टाइम क्या हो जाएगा? Distance by speed. डिस्टेंस गिवन है हमारा 2.5 किलोमीटर और स्पीड गिवन है 5 kmph। दैट मीन्स सी विल टेक हाफ एन आवर टू रीच हर ऑफिस। अगर उसने अपने जर्नी को 9 AM पर शुरू किया, 9:30 में वो अपने ऑफिस को पहुंच जाएगी। 5 बजे के बाद आफ्टर 5 PM मीन्स सी स्टेज एट द ऑफिस अप टू 5 PM एंड देन सी रिटर्न्स होम। आई वुड लाइक टू फाइंड आउट द टाइम वंस अगेन, टाइम टेकन बाय द वीमेन टू रीच हर होम। टाइम इज इक्वल टू डिस्टेंस बाय स्पीड। अगेन वी हैव द सेम डिस्टेंस 2.5 किलोमीटर and the speed is different, which is 25 kmph. Our answer will be 0.1 hour, that means 6 minutes. She will take 6 more minutes to reach her home after completing her work from the office. B to C जो distance covered है वो कितना हो जाएगा? 5 PM से हो जाएगा वो 5-6 PM. Okay everyone, now we have our next question here. As you can see, a drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward and followed again by 5 steps forward and 3 steps backward and so on. Each step is 1 meter long and requires 1 second. We have to plot xt graph of his motion, determine graphically and otherwise how long the drunkard takes to fall in a pit 30 meter away from the start. As you can see here, that drunkard takes 5 steps forward and 3 steps backward. The total step taken by the drunkard in the forward direction will be 2 steps and he takes 2 steps in 8 seconds. And it is given in the question that drunkard will take 1 second to cover 1 step and 1 step is equal to 1 meter. We can say that the drunkard will cover 1 meter of distance in 4 seconds. Okay. For the first 8 seconds, drunkard will take 8 into 4 is equal to 32 seconds and for the next 5 meter, that drunkard will take 5 more seconds. So the total time taken by the drunkard will be 32 plus 5 is equal to 37 seconds. I hope you all have got it. Now we have to make a graph, that is we have to plot a xt graph of his motion. So as you can see here, that drunkard takes 5 meter distance, he covers 5 meter of distance in the 5 second, and then just a 3 step backward in the next 3 seconds. So we can draw this kind of graph for all his steps, like 5 step forward and 3 step backward and so on. So at last you can see here that he takes 37 seconds. 37 seconds. Now we have our next question here. So question says a car moving along a straight highway with a speed of 126 km/h is about to stop within a distance of 200 meters. What is the retardation of the car? And we have to assume it uniform. And how long does it take for the car to stop? First of all, initial velocity is given 126 km/h, that means 35 meters per second. So we will convert that into meters per second. Distance is given 200 meter. So first of all, I would like to find out our acceleration. And for that purpose, we will use our formula v square is equal to u square plus 2as. So we will get our answer, which is a is equal to minus 3.0625 meters per second square. Now to find out the time, we will use our formula v is equal to u plus at. So our time will be equal to 11.42 seconds, and this is how we are solving our questions. So I hope it is clear to all of you. Now we have our next question here. So question says a player throws a ball upward with an initial speed of 29.4 meters per second. So question A says here that what is the direction of acceleration during the upward motion of the ball? So as we know, acceleration due to gravity is always act downward towards the center of the earth. Now question B says what are the velocity and acceleration of the ball at the highest point of its motion? So as we know, at the highest point the velocity will be 0, but acceleration that will be due to gravity, which is equal to 9.8 meters per second square, right? Now question C says here, choose the x is equal to 0 meter and t is equal to 0 second to be the location and the time of the ball at its highest point, and vertically downward direction to be positive direction of the x-axis, and give the sign of position, velocity, acceleration of the ball during upward motion as well and downward motion as well. Okay, so as we know that if you are choosing x is equal to 0 meter and t is equal to 0 seconds, so at the highest point, so what we can say, so during that upward motion of the ball, so before reaching the highest point, position x will be positive, velocity will be negative, and acceleration will be positive. And during the downward motion of the ball, after reaching the highest point position, velocity, acceleration, all three things will be positive here. Okay everyone, now we have our next question here. So question says a ball is dropped from a height of 90 meter on a floor. There is a ball and we drop that ball, this is our floor here, and this is our total height, which is given 90 meters. Okay, and each collision with the floor, the ball loses 1/10 of its speed. So for example, its initial speed u is equal to 0, and when the ball hits the ground, it will have some final velocity, and with that final velocity it will rebound. So it is given that the ball loses 1/10 of its speed. That is the question. So we have to plot the speed time graph of its motion between t is equal to 0 to t is equal to 12 seconds. So first of all, you can see here height is given 90 meter, u will be 0. We have to find out v. We will use the formula v square minus u square is equal to 2as. So our v1 will be 42.43 meters per second. And to find out the time, we will use our formula v is equal to u plus at. So t1, that will be equal to 4.24 second. Now to find out v2, according to the question, we can say that v2 will be equal to v minus 1/10 of v, which is equal to 38.19 meter per second. So similarly, T2 will be equal to 38.19 divided by 10, which is 3.819. So the total time will be equal to 4.24 and plus 3.819, that will be equal to 8.05 seconds. So we can say that now the ball will travel back to the ground in the same time as it took to reach the maximum height. So that will be also same, 3.819. So total time will be 4.24 plus 3.819 plus 3.819 is equal to 11.86, approximately 12. So V3 is equal to 9 by 10 into 38.19 is equal to 34.37 meters per second. And this is how we can plot the graph. So first of all, as we can see that U is 0 and our V1 is 42.43 approximately. And then we have our V2, and V2 that is given here 38.19, and then we have our V3, and which is 34.37 meters per second. So this is how we can plot the graph here. So I hope it is clear to all of you. Now it's time to solve our next question. So question says, a man walk on a straight road from his home to market, from his, let's say it's home, and here we have the market. Okay, here we have the market. So distance between the home and the market, which is given 2.5 kilometers. So a man walks on a straight road from his home to a market 2.5 kilometer away at a speed of 5 km/h. 5 km/h. Finding that market is closed, and he instantly return and walk back home with a speed of 7.5 km/h. We have to find out magnitude of average velocity, average speed of the man over the interval of 0 to 30 minutes, 0 to 50 minutes, 0 to 40 minutes. So now let's solve it. So as you can see here, distance is given 2.5 kilometer, that is equal to 2500 meters. And if we convert 5 km/h into meters per second, that will be equal to 1.3888. And 7.5 kilometer per hour, if you convert that into meter per second, that will be 2.08 meter per second. And first question is we have to find out average velocity. So that will be 0 because displacement is 0. And the time taken to reach the market. So that will be equal to distance by speed. That means 2500 by 1.3888 is equal to 1800 seconds. And similarly, average speed over 0 to 30 minutes, that is 5 kilometers per hour. And the next question, that is time taken to reach back home, that will be equal to distance upon time is equal to approximately 20 minutes. Okay, now so we can say that the average speed over an interval of 50 minutes, that will be equal to total distance divided by total time, and we will get our answer 1.66 meters per second. And if we find out average speed between 0 to 40 minutes, so that will be 2500 plus 1250 divided by 24, which is equal to 1.56 meters per second. Okay everyone, now we have our next question here. So question says, we have carefully distinguished between average speed and the magnitude of average velocity. So no such distinction is necessary when we consider instantaneous speed and the magnitude of velocity. So the instantaneous speed is always equal to the magnitude of instantaneous velocity y. So as we know that it is, if we just say about instantaneous speed or the velocity, so it is applicable for very short interval of time. So because of that, the magnitude of displacement is effectively equal to the distance traveled by the particle. So we can say that the instantaneous speed is always equal to the magnitude of instantaneous velocity. Okay everyone, now so we have a few graph here from A to T. We have to look at the graph very carefully, and we have to give the reason like why or which of these cannot possible represent one dimensional motion of a particle. First graph is xt graph. You can see here xt graph. Let's say if I take a time t at any point, let's say this is our t1. So you can see at some instant we have two displacement or we have two distances, which is not possible, right? So this is not possible. Now if you look at the second graph, which is v versus t, now if I take any time here, let's say this is t1 once again. So on the same time we have different directions of the velocities, right? We have two velocities here, one is positive and one is negative, which is not possible. If we take our speed, so we know that a speed is always positive, it can't be negative. But you can see that negative part of the speed, this is also not possible. And the d part, total path length, so now you can see that we have all these three and four graph. So total path length decreases in time, the total path length decreases in the graph. So this is also not possible. As you can see that the total path length is given in the previous one, that total path length is given which is decreases, so which is also not possible. Okay, because path length can never be decreased. So and if you remember the previous class of kinematics, we have discussed different types of graph which is not possible, right? So I request all of you once again, if you have not seen that video of kinematics part 1, so please go to that video and have a look at that video. Okay everyone, now we have our next question here. So question says a police van moving on a highway with a speed of 30 km/h and fires a bullet at a thief car speeding away in the same direction with a speed of 192 km/h. If the muzzle speed of bullet is 150 m/s, with what speed does the bullet hit the thief's car? And we have to note that obtain the speed which is relevant for damaging the thief's car. So as we can see here, the speed of police van is given 30 km/h, that means 25/3 m/s. Next one, a speed of the thief car which is 160/3 m/s, and the muzzle speed of the bullet is 150 m/s. So we can say a speed of bullet is equal to speed of the police van plus muzzle speed of the bullet, that will be equal to 475/3, right? So the relative velocity of the bullet with respect to thief car, that will be the speed of bullet minus speed of the thief car. So we have to subtract it. 475/3 minus 160/3 is equal to 105 meters per second. So quite a simple question that we have. So here we have one more figure. It gives xt plot of a particle executing one-dimensional simple harmonic motion, and you will learn about this in upcoming chapters. So give the sign of position, velocity and acceleration variable of the particle at t is equal to 0.3, 1.2 and minus 1.2 seconds. So to solve this question, we have to know the formula or the relation of simple harmonic motion. So we know that, you can see here, acceleration of SHM, which is simple harmonic motion, A is equal to minus omega square x, where our omega is angular frequency. So at t is equal to 0, x is negative according to the graph. So if x is negative, then slope, and also the slope of xt is also negative. So we can say velocity will be negative. So from equation 1, we can say A will be positive. From equation 1, we can say A will be positive. At t is equal to 1.2, x is positive here according to the graph. Slope of xt will be positive. It is also in the graph. So we can say that velocity will be positive here. So again, from the equation 1, we can say A will be negative. But at t is equal to minus 1.2 seconds, x is negative and slope of xt is positive, so velocity will be positive. So we can say A is positive here. Okay everyone, I hope it is clear to all of you. Now we have one more question here. So figure 2.15 gives a speed time graph of a particle in motion along a constant direction. 3 equal interval of time are shown. In which interval is the average acceleration greatest in magnitude? First question. In which interval is the average speed is greatest? And choosing the positive direction as the constant direction of the motion, give the sign of velocity, acceleration in the 3 interval, and what are the acceleration at the point A, B, C and D. So now you can see the change in the speed with time is maximum in interval 2, right? In interval 2, we can see the change in speed with time is maximum. So we can say that the average acceleration is greatest in interval 2. Now The average speed is maximum interval 3. Now the third one, you can see the sign of velocity is positive. The sign of velocity is positive in interval 1, 2 and 3. And the acceleration depends upon the slope. So if the slope is positive, our acceleration will be positive. So acceleration is positive in interval 1 and 3. You can see interval 1. So our slope is positive 1 and 3. But if you are see that slope 2, so here we have the slope is negative in interval 2. So our acceleration will be negative here. So acceleration A, B, C and D is 0 since the slope is parallel to the time axis in this instant. A, B, C, D is 0 because if you see that A, so our slope is parallel to time. At B, our slope is parallel to time. At C also and at D also. So we can say that that our acceleration is 0 on these instants. Okay, everyone. So if you have some doubt, you can discuss with me, and I believe that it is clear to everyone. So I request all of you, keep learning. We can meet again. So because I feel together we can make a difference. So take care everyone and keep learning.